A good day, everyone. My name is Mark Aldrin A. Nabre, and I'm here today to discuss with you about the electric potential and potential difference. What is electric potential and potential difference? Electric potential and electric potential difference are concepts in the field of electromagnetism that describe the electric potential energy per unit charge. So the potential is characteristic of the field only, independent of a charge test particle that may be placed in the field. So potential energy is a characteristic of the charge field system due to an interaction between the field and a charged particle placed in the field. So here's the formula. So for the formula for electric potential is B equals to U over the Q. So V is the electric potential, U is the potential energy, and the Q is the charge. So an electric potential difference between 2 points in this work done per unit charge in moving a positive charge from one point to another. So as you can see in the picture, the where the delta V is the electrical potential difference, then the W stands for the work done, and the Q is the charge. So when analyzing electric and magnetic field, it is common practice to use the notation ds to represent an infinitesimal displacement vector that is oriented tangent to a path through space. So this path may be straight to the curb, and an integral performed along this path is called either a path integral or a line integral. So the two terms are synonyms. So because the potential energy is scalar quantity, the electric potential also is a scalar quantity. So here in this definition, the infinitesimal displacement, or the ds is interpreted as the displacement between two points in space rather than the displacement of a point charge. So electric potential is a scalar quantity. And so it tells us how much electric potential energy a unit positive charge would have the particular point in space. So it is important to note that the concept of electric potential is independent of the test charge used to measure it. So the electric potential, or the V, is a measure of the electric potential energy per unit charge at a given point in an electric field. So similar to the potential energy, only different in electric potential are meaningful. So to simplify calculation, a convenient point in the electric field is often chosen as a reference, and the electric potential is considered to be zero at the point. So potential difference, or the delta B, is not the same as the difference in potential energy. So the potential difference between the 2 points in an electric field is created by a source charge and depends on the distribution of the source charge, and so it exists without the presence of a test charge. So in contrast, potential energy, it requires a system of two or more charges. So the potential energy belongs to the system and change only if a charge is moved related to the rest of the system. So if an external agent moves test from one point, example a capital A, to another example, a capital B, without changing the kinetic energy of the test charge, the agent perform works, or capital W, the change that potential energy from U, so of the field system. So the work done, or the W, is equal to charge change in the potential energy in delta U. So the potential is a characteristic of the electronic field itself, and it independent of a charge test particle that may be placed in the field. So on the other hand, potential energy is a characteristic of the charge field system and result from interaction between the field and charged particle placed in the field. So So the work done, or the W, by an external agent is moving charge from Q through an electric field, and constant velocity is what's given. So here's the figure. So where the W is the work done, and the Q is the charge, and the delta V is the potential difference. And that's all for my presentation. I hope you learned something, and have a great day, everyone.